This video is about conduction, about how heat is transferred in solids. And we're going to look at a number of different little demonstrations so our understanding of conduction increases more. So first of all, I've got a beaker of hot water here. It's just boiled. I've just poured it out. Into this, I'm going to put copper, brass, aluminium, glass, wood, and plastic. Now, basically, I'm going to touch the ends of each and to see what we notice. I'm going to give them just a little while to get used to it. And now, if I touch the copper, so the brass, I can feel that's quite warm at the top already. If I touch the brass, the copper, that's even warmer. And if I touch the aluminium, that at the top is warm as well. Now, if I touch the wood, I can't feel any change. Likewise, the glass, still feeling very cold. And the plastic, again, there's no real change. So we can see these we can group into two groups. The ones which get hot and allow the heat to pass through quickly, these are called conductors. And the other ones, the other materials which don't allow the heat to pass through easily, we call non-conductors or insulators. Now, this is a qualitative one because we're making no measurements. The next one I'm going to do, I'm going to look at a more quantitative approach. So in this, we're going to look at a more quantitative approach. This piece of equipment consists of 4 metals: steel, brass, aluminium, and copper. Below that, I've got the beaker of the hot water, and attached to each of the 4 metals are liquid crystal thermometers. I'm going to lower the ends of the metal into the hot water, and we'll look to see which one's heat passes through quickly by looking at the change in temperature. So, as we can see, the copper is changing, the heat is passing up through there and it's changing quickly. Steel is slow. Aluminium is pretty fast. And brass just a little bit faster than steel. So as we can see already, the copper has reached the top, it's green. The aluminium is approaching the top now in terms of colour changes, and it's reached there. And steel, not very far. Brass is about 2/3 of the way up. So this gives us a more quantitative approach. So we can see from these results that obviously because copper, the heat reached the top fast. This first is the best conductor. Next was aluminium. And in terms of the way we're going now, brass will be third and steel will be last. Now, another way we could get quantitative results is from this piece of apparatus. I've got 5 metal bars coming out from a solid centre. Attached to each of these bars is a drawing pin which is stuck onto it with a piece of grease. Now, if I heat, which we're going to do, the centre, because the drawing pins are the same distance from the centre spoke, if we look at the order at which they melt and fall off, that will give us an idea of the best conductors. So we've got brass, we've got copper, we've got aluminium, we've got steel, and we've got iron. So let me just get this set up and we'll look. So I'm heating the centre. Because they're all the same length, they'll all get the same amount of heat. It's a question of which one lets the heat pass through fastest. So the first one that went there was our aluminium. Then copper. Now brass. Then steel. And last would be the iron. Now, in terms of the best conductors then, from this experiment, it would appear to be that aluminium is the best, then copper, then brass, then steel, and finally iron. How could we make it more, what could we do to this experiment to improve the nature of our results?